Hello and welcome everybody to today's Tech Talk about the inert gas flow. Today we learn why the flow is so important in order to get a high quality metal laser powder bed fusion process, like in M400s in the back of us. Like you can see in the video, the smoke coming out of the melt pool and how the flow is acting on the smoke coming out of the melt pool. Therefore, I invited a true expert in the field of aerodynamics, Sebastian. Welcome to the show.
Thank you for the invitation. Hello, everybody.
And my first question, of course, will be, what are the main tasks of the inert gas flow, Sebastian?
So the main task is to remove the dirt that our process will create on the powder bed. So if you see, this is the powder bed, and here we have the laser coming from the top of the machine. And the laser will heat up the powder bed, and the powder bed will start to melt, and it will start to evaporate some material. And those material will create some smoke. Those evaporated material will create some smoke, and this smoke will reduce the power that our laser will have on the powder bed. So therefore we need something to get rid of the smoke, and therefore we need some gas flow. So once again, this is the powder bed. Here we have the laser coming from the top, and now we introduce some gas flow, and the gas flow will simply blow away the smoke. This is one of the issues that we are going to solve with the gas flow, and the other point is better. So when you have a look at our process itself, you see some sparkling particles flying out of the process itself. Those particles are also created in the melt pool. It's some molten material that comes out from the melt pool, and also some powder particles that are thrown away from our process. So we want to avoid that those particles drop on the powder bed, because else it will create a bad process when we have those particles in the powder bed. And this is another issue that we can solve with our flow. The gas flow also will simply blow away those particles, and will avoid that those particles drop on the powder bed.
And the third task of the flow, of course, is oxygen pickup. So the process chamber is filled with either nitrogen or argon in order to prevent that oxygen is acting on the quality of our part.
Exactly. Yeah.
So Sebastian, what about design concepts? So you talked about the basics, and can you give us some background about different design concepts of the flow?
Of course, yeah. So it's quite hard to find a good design concept, because one issue that we have with this gas flow is when the gas flow is too fast, it will blow away the powder, and on the other hand, if it's too slow, the dirt will rise too much. So therefore we really need to have a good design of the process chamber to avoid areas with low velocities, and also to avoid areas with high velocities, because the gas velocity band that we're able to use is very narrow. And so that's one of the design issues that we really have to care about. And one other issue is, if you have a look in our process chamber, so that's the bottom of the process chamber. This is the main gas inlet. This is the process chamber itself. This is the main outlet. Here we have the powder bed. So if we have just one main flow coming in here, leaving there, so this is the main flow. If you would have just this main flow, then we would create a big swirl over here. The gas that moves here will start to move this gas in a big swirl, and this big swirl will take up the dirt from here, bring it to the laser window, and this will once again create a bad process. So that's one thing that we want to avoid, and therefore we need a second flow coming from here into the machine, and the second flow will push down the swirl that tries to start here, And also this second flow will go on the top of the process chamber and keep the process window clean. So yeah, the second flow basically will avoid that some particles start to agglomerate somewhere there and to obstruct our process there.
Okay. Do we have any other concepts?
Yeah. So that's the older concept. In the newer concept, we did some optimization. So once again, we have the bottom of the process chamber, we have the powder bed here, the main flow inlet, the process chamber, the main outlet. Yeah, once again, the main inlet, main outlet. And instead of having just a spot nozzle over here, we have a perforated plate over here and over there. And so the second flow comes all over the ceiling. So therefore we have a very slow flow over here, but it's very even distributed. And this flow here will take every particle, every bit of smoke that moves in the top of the process chamber and will remove it through this side. So that's the newer concept, which leads to a more even distributed flow in the whole machine and in the whole process chamber.
Okay, and we're also able, of course, to mix the amount of flow coming from the upper part and the one just flowing over the process itself. Mm-hmm. So we heard about single laser systems, but what about multi-laser systems like the M404? Mm-hmm. So do we have any specialties in regard to the flow?
Yeah, when it comes to multi-laser systems, we really want to avoid that one laser builds in the dirt of the other laser. Because then once again we will have this laser smoke interaction and bad parts. And one thing that we, therefore we decided to use a different flow concept in the M404. So once again, this is the bottom of the machine, this is the powder bed, and now we have two outlets, and this is the process chamber itself. And here we have a flow from the top of the process chamber, which goes to the left and to the right. And we decided to use that flow concept because when you have a look on the process area itself, on the powder bed itself, when you have a look on top of the process area, you can see that our lasers, every laser has its quarter where the laser is able to work. And therefore we know where the lasers will be, and therefore we can try to make a flow design that is able to avoid laser smoke interaction. So the flow that comes from here will blow in this directions, and so the smoke that is created here will be blown out of the machine, and so there's no way that the smoke from this laser may interact with this laser.
What about new concepts?
Yeah. So in new concepts, when you want to do a full field overlap, you're not able to use a flow design like this. In this case, you need to use some software tools to avoid that one laser builds in the smoke of the other laser.
Okay, thank you very much, Sebastian. I guess we learned a lot about the Inert Gas Flow today. So once again, thank you, Sebastian, and
my pleasure.
Thank you for watching, and stay tuned whatever we talk about next time.